we're probably, I would say that this is, with logic, loops, and functions, and arrays, those are like really the foundations of using MATLAB. And today we're going to be doing functions. And I also would say that probably people find functions to be one of the more difficult concepts to understand. I'm not exactly sure what it is. I'm trying to figure that out, but I get a lot of students who by like topic 9, they come to me and they're like, "Oh my God, I finally understand functions." So it takes a lot of practice. But it's a big shift because it really changes the way that we're going to be writing our functions. So up until this point, we have only been writing script files. And a script file is a really straightforward concept. It just contains a list of commands in a particular order, in line order, that are executed one at a time by MATLAB. And they're really just for convenience so that you don't have to keep re-entering commands in over and over in the command window. So functions do the same thing, but the difference is they allow things to be inputted and outputted to them. And so while they aren't vastly different than a script file, they only just allow things to come in and things to be sent out. They totally change the way that you can develop and organize your code, because you can start placing things in different parts of your code and calling on them. And I think that's probably what confuses people the most, because once you start writing function files, the code doesn't necessarily read from top to bottom. So in order to write a function, you start by writing what's called a function declaration line at the top of your file. So a function declaration line starts with the word function. That's another one of those special words like for and while and end that you can't use for anything else. So it'll turn blue. And then within the function declaration line, you're going to put the function name. And this should be the same name that you also name the file, unless you have multiple functions within a file, and then there's some more rules that you need to be aware of. And behind the function name is where you list any inputs that you would like to declare. And then in front of the function name, in square brackets, you list any outputs. So the function name, the inputs are always using parentheses, and there can be one, none, or as many as you would like of inputs, and they're just separated by commas. Same with the outputs. There can be none, there can be one, or there can be as many as you'd like. And it's really important that you know the naming convention for functions and files. So the best habit to get into is the top function should have the same name as the file name. However, if you you know how sometimes you're writing a file and you want to change the file name because something isn't working or you created a second version? If you don't have them as the same name, the file name overrides the function name. So basically the function name doesn't matter. So the file name is sort of like top tier priority. And then, so you have this function declaration line, which just tells MATLAB what you want to be allowed to come into the file and what you would like to send out. But other than that, everything else is the same as a script file. You should start the script file with some comments that explain the functionality of the file. This is particularly important with functions because you yourself might forget what you're supposed to input as inputs or what comes out as an output. So it's really important to get into the habit of describing that at the top of your file. And then you just have all of your code listed as normal, and then you need to end the file with the word end to close the function, and that will be a wrapper that will be connected. So again, it's really important that you remember, use parentheses behind the function name, square brackets in front of the function name, inputs on the right, outputs on the left. And again, you can have a function that has 0 inputs and 0 outputs. So you could write the function declaration line and you could leave off the entire inputs, no parentheses, and the entire outputs, no equal sign, no brackets. And it still works as a function file. So before I show you some examples, I want to move over into MATLAB to just show you, oh sorry, you were watching that on my computer, how you can, what some of the tools in MATLAB to create function files. So I've showed you this when I showed you how to write a script file, but there is a template for functions. So if instead of clicking script, if you click function, you'll see that there'll be a blank function declaration line that you can then fill out with the outputs, inputs, and function name. However, there is nothing special about that template. It is just a script file, so you can just create your own, and that it becomes the exact same functionality as the wrapper. I think some people at first feel like function files are a different type of file, but they're not. They're just both M files, and they can be converted very easily from one to the other. Okay, so let's talk about some of the functions that you already know. I'm just going to keep it on there actually. So I've mentioned this before, that one difficult thing about learning how to do MATLAB is that in order to do anything in MATLAB, you kind of have to be able to do everything. So like the first day that we used MATLAB, we had to start using functions, but there wasn't really time, or you weren't really ready to start thinking about what a function was, right? So you've already been using functions quite a bit. So for example, we've used some of the statistical functions and the functions that operate on arrays. So one example is the min function. So if you have an array and you type in min and then give the min function the input of v, which is an array with some number of elements, this is an example of calling a function with one input. And if you don't do anything and you let this command run, it's just going to print to screen the output that is saved in the min function, which is just the value of the minimum, right? And so it just is going to print to screen and save to the default variable ANS2. What we typically do is we want to actually use that output, right? And so what we'll do is we'll save the output to a variable name. So instead of just letting it go to the screen or go to the ANS variable, we'll save and hold on to that output as MN. And so then the minimum goes to that variable. So this is calling a function with one input and one output. Now using the intrinsic functions is a little bit confusing because they're a little bit fancier than the ones that you'll write to some degree. And the reason I say that is because they allow you to have, some of these are optional. So for example, in order to use the min function, it doesn't work unless you give it at least one input. It'll throw an error. So that's not optional, but outputs are always optional. So if there's multiple outputs listed, you can choose to save just the first one, the first two, the first three. That's a choice you get to make. Where inputs aren't the same way. So if you add a second input to the min function, it's also going to save the location, right? So for this one, mn will equal 2 and end will equal 1.
So when you're writing your function, and you're saying that you could use 0 or 1 or as many as you want for inputs and outputs?
Yeah.
If you use 0, you wouldn't be able to use 2 outputs when you're asking the function to do what it's doing.
Yeah, and I haven't been very clear about that. So what I meant to say is if you're defining a function, you can choose to define a function with 0, 1, or many inputs, 0, 1, or many outputs. Once the function is already written, like the min function, there are going to be some rules about how many. So the min function needs at least one input to operate. But if you were writing your own function that didn't require an input, then it could have 0 inputs. That's what I meant to say.
You're also limited. Like if you wrote a function that had 0 or 1 output, you wouldn't be able to use 2 outputs.
Yes. You definitely can't ever do more than what was ever programmed. That will always throw an error because it won't have it will not be able to find that second one or whatever you put in. But as an example for that, since you use the input function, you know how the input function, you put in a string and it prompts the screen with that string. So you can just put in one string, right? You can just put in one string and then it prompts the user. But it also allows you to add a second input to say that the variable received is going to be a string. So we did that when we wanted to have the user put in like their name or something rather than a value. But when you left that off, the function still operated normally. This is because MATLAB has done some more advanced coding to allow for either inputs, but for any code that you wrote, if you're using both inputs in the code, they have to be provided when you call. But those are just some examples of ones you've already used that you haven't written but that you've been using. And the nice thing about MATLAB is it used to be really user friendly in the sense that you could go in and like find the min function and you could read the mfile code and you could just like see exactly how it was written and how it worked. But they've like as of maybe 5 years ago or something, they've blocked all of this. You can't see any of them anymore. So the software is just structured in a different way that you don't have access to that. But the whole idea of MATLAB and the strength of MATLAB is that it does allow you to make your own functions that operate exactly the same as all these intrinsic functions. So if you, what I'm going to show you for the rest of the time is writing your own user-defined functions and how that works, and and how to structure your code a little bit differently so that it can be more organized using functions. So let's start with, I'm just going to show you a bunch of examples now of how to write a bunch of different functions. In your lab, you are going to write, I think, 3 or 4 that I'll call each other. So I'm going to start off really simple with this one that I've already started here. And because this is actually a lot of intrinsic functions need things to be defined this way, so that's why it's a good one to start with. So let's say that you have a function f of x that depends on, it's just some quadratic function. I'll type it out, just x squared plus x minus 2. So this is a function, and let's say you were doing something with this function that you needed the function to be evaluated at different points, but you didn't know what points there were. So it's not like you could just set an array with a step size of 0.1 and then just get all the function values at those. Let's say you didn't know what x you might need a function defined at, so you wanted to be able to put in any x and get out any f. So this is an easy function. It's one line in itself, so it doesn't really make sense to put it in its own function. I'm saying the equation is one line. The way that you define f is simple. But just for example's sake, this is what I'm going to show. So what you'll see is that when I start typing the function, I don't have it saved yet. And so if I save it, it'll by default suggest the name of the function. And so that's what you want to use. That's what I was saying. So I'm going to save this, and it has the same file name as it has function name here. And then what I can do is now MATLAB recognizes this just like it recognizes the script file. And so if I type in and find my function name, the difference now is if I try to run it, well, first of all, I think a lot of people get in the habit of just typing run. But whether I type run or I type in the file name and enter, there's going to be an error because it needs an input in order to do anything in this code, right? It doesn't know what x is, so it can't even execute the first line of code, so it throws an error immediately. It says, well, I don't know what x is. And the nice thing about functions is if it can't find an input variable, it tells you that specifically. So instead, when you call the function, just like when you call the min function, you have to provide it an x. And basically 3 goes to x, and then anything in the code that refers to x uses that value. And then if you run it again with a different number, then x is now 5. And so anything that's using x is going to be referring to whatever was inputted in. This is printing the output f. If I didn't have this output defined and I ran this, nothing would happen because everything in the code is suppressed, right? There's nothing printing to the screen. There's no output defined. But the default for functions is that if you have a output defined, that output gets printed to the screen. And so if you don't want the output printed to the screen, you have to suppress the function line call. And so you want to get in the habit of doing that because you're going to start calling functions that have long outputs with big arrays, and so you don't want those to print to the screen either. Let's see. The inputs can also be arrays. So let me just try it and see if you can. So I'm going to put in an array, and so I'm getting an error because I'm trying to square an array, right? So if I want to be able to do this on an array of x's instead of just one, I would need to put a dot there. That would also operate for the scalar equivalent, right? And then you can see my input and my output are now just arrays, but they behave the same. They're just the same, saving them as a variable. Any questions so far on just like the simple input-output function? Okay, and you can imagine that there could be anything in this function, right? Like anything could happen in these lines to use the input and to define the output. And then when you call it, you can define the output f to a variable, and I'm going to use f1. This is probably one of the more confusing things people find about using functions is these variable names. So even though I called this f, I don't have to call the output when I call it f. I can call it whatever I want. Because typically you write a function because you want to call something many times, right? So there would be really very little reason that you would be calling a function and using the same variable name because you're probably trying to save multiple. So let's say the first time you run it, you call it f1, and then the next time, let's say you need to run it again but with a different x, call that f2, etc. And so every time you run it, you save the output to a different variable name, and then you have it for each time.
You have to put it in brackets.
I don't think you do with one. You don't have to with one, but if you have more than one, you have to. I think the same goes for the declaration line, but it's like a habit. Okay, so now let's talk about calling this function inside another function. So what I'm going to do is I'm going to start by calling it inside a script file. So I'm just going to save this file as test4, and I'm just going to copy these lines of code into the script file. And because these files are both saved on my desktop, they have access to each other. And so when I run this file here, you can see that the file is executing all 3 lines of code. And let me just show this really quick. So I'm going to clear out my workspace here, and I'm going to now run this file. So just like your normal script files, everything that was defined went into the workspace, right, within MATLAB. And that's how it normally works. So if you're like debugging a file and you want to figure out what a variable is, you'll run your file and then you'll like double click on it to see what the variable is or whatever. So that'll all work as normal. What's different though is, let's say that I'm writing this as a function. So I'm going to convert this into a function. And now everything is exactly the same. There's no inputs to this function. This function still has one input, one output, and I'm calling that function from this function. But this function test4 has no inputs, no outputs. So I can use the run button to run it, right? Because it doesn't need any inputs. I'm going to clear out the workspace. I'm going to run this again. And what you'll notice is those variables do not show up in the workspace. Because functions, and this will be in your pre-lab, we call them black boxes. So it's like you don't know what goes in and what goes out of them, except for the inputs and outputs. And so when you run function files, which is what we're going to do for every other file that we write, you'll need to pay attention to that. So if you're debugging, you're going to want to remove the function declaration line so that you can see stuff. If you're using inputs and outputs, then you can't do that. So you might want to kind of work on your file and then add in the inputs at the end. So some people think like, well, why would you ever want to do that? But for a lot of the programming that I do, for example, I don't want them to come to the workspace because I want to use the same variable names in different spots in my code, and I don't want them to get confused with each other. And so that's why I use functions.
So in that script, or that M file, the test function is saved somewhere else, right?
Yes, they're both saved here in my working directory. So
because of that, you can use that.
it is because of that for my computer, but it is true that different computers are different. So some computers will go search for function files. Especially if you just go into folders, not back from folders. Most computers will search within folders, but MATLAB changes that a lot, so you always have to check. But yeah, you should just keep them in the same folder so you're sure that you're using the right file. Which brings me to the next thing I want to show you, which is how I normally would write this. I don't like to write my code so that I have a bunch of different files, especially if I have functions that are short like this with just a few lines of code. Instead, what I prefer to do is put them in the same file. So I'm just dividing up my code in this way. So what I'm going to do is I'm going to take this test function script that I wrote and I'm going to get rid of it. I'm going to delete it. And then I have placed it at the bottom of this file. So now the code, again, nothing is happening, but the code is running just as normal. And it's calling on this function, the one that I just put underneath it. So the way that MATLAB works is it first searches your file for any functions with the name that you called on. If there's no functions within that file, then it searches within the folder, and then some computers search further than that as well. And so this is what I was saying. We were so used to reading code from top to bottom, but with functions, the code separates itself. So when you run a file that's a function, it only runs the code in the first function. So for example, if, let's say I never called test function, and instead I just did some other stuff within this file, within this function, it would run that code, and this code never gets written. In fact, you can, I don't know what kind of errors you can have, but you can have things in here that don't make sense, like there's no alpha. But because this code never gets called, it doesn't even check it within MATLAB. But then as soon as you call that code, then it's going to do all of its regular checks. You know, there's no variable there. Alpha needs to be defined, kind of stuff. So what it's doing is with functions, and this is the same as with using intrinsic functions, is it goes through line by line, top to bottom, executes line 4, line 5, it goes to line 6, and it just searches for the function name. And this is also a case where you can overwrite functions that already exist. So if you want to call that the min function, then that's now the min function, and now the regular intrinsic min function does not work in this file anymore. But there's no order to these functions. So if you had multiple functions that you were dividing up your code into, doesn't matter. You don't have to call like min1 first, and then min2, and then min5. You can call them however you want. It doesn't matter. Because of the wrappers, the function, and the end, the order of the declaration of the function is irrelevant. The only thing that matters is that your first function is the one that gets run. So for your lab that you're working on, this is how I would like you to write it. I would like you to write it as one file. The main reason is because it's self-contained, and so for me to run your files, if all of you write a function, all these same subfunctions, I have to save all of them as special names and run them. But if I download just one file for each of you, then they all call each other's files the same. But it's just a preferable practice for a lot of reasons that I use anyway. So I think it's a pretty good one to use. So what I'd like to show you now, do you guys have any questions about like how functions call each other?
Oh, is our lab going to be called for a function? Is it going to be lab 6, the function name?
Mm-hmm. Yeah, so I always have the top file called the name of the function, or the name of the lab, and then if you write any subfunctions, they have particular names, yeah. This was really important during the semester class because we do quizzes, and every quiz was structured this way, but Cody coursework doesn't have this, so it doesn't matter. Okay. Any other questions? Oh, one other thing I wanted to just say with these is the idea of a nested function, because that someone always does this. And so right now, do you see how the function end, they're completely separated from each other? That's in almost every case what you want to do. You almost never want to do what I'm about to show you unless you're doing something like really fancy. But what I see a lot of people accidentally doing is nesting a subfunction within another function, and then it can't find this one. And so, or forgetting ends kind of gives you the same error. Let me just, I don't even know what this does. Yeah, because this one, it might work, but it can get very confused when you start doing this, when you have functions nested within them. The reason to nest functions is that you can, if you have like a variable defined here, m equals 3, then you can use m here. You don't have to define it. It doesn't need to come in. However, if I put this here, did everyone just see what I did? I have m defined here, and then I can use m in this function. It turned blue because it made it like global. However, if I put it here, it's not going to know what m is anymore because this function only knows what's coming into it. It doesn't know anything else. It doesn't know anything in this function. And so that's why it gets a little bit confusing when you start nesting them. I find it much more simple when you first start programming to just keep all your functions completely separated. So what I wanted to do is go through an algorithm that I basically want to go through an algorithm that removes duplicate letters from an array. So for example, let's say that you had an array and some of these words were collected using some instrument, but the instrument sometimes failed and repeated letters incorrectly. And so just to keep it simple, I've just repeated H's, just so you can see it. And so I want to go through kind of the thought process of writing an algorithm that removes those extra letters. And so I wanted to go through like, well, maybe I'll just show this because I don't have time to write it all out. So I'll just show it and then we'll write out the code for it. So the idea is that you have this text array and you need to create a conditional check to see if one of the letters is an H, because you know that the instrument only repeated H's. So it's a little bit hard to see this, but if it's an H, then you know that you might need to double check that there aren't two H's. And so let's say you were just thinking about like the first element. So you started with element 1. If it's an H, then you want to go through and check, well, is there another H next to it? So does text 2 also an H? And if it is, then you would want to remove one of those H's. And you would do that for the first one, and then you would go through and repeat that process for the next one, and then the next one, and the next one. So this is what I have told you before, is like me kind of having you think about like just how you do it as a human. And then what I've written in green is converting it into kind of like MATLAB equivalent. So first you need data, so you need a variable definition or an input. The check is an if statement. You have another check. Removing an element, I think I showed you guys this, right? I showed you this in the arrays section, that if you set an element to an open and closed square bracket, it takes it away. And then number 5, which is to just keep repeating, is going to be a while loop. And so I just wanted to kind of build this function for you guys in MATLAB and then see if we can get it to run. So once you have kind of that written out, you could go forth and write a pseudocode. But for now, I'll just stick with starting out the code. So the first thing you want to do is start wrapping everything correctly. So anytime you have a loop, you're going to start with that wrapper first. And remember we had those two if statements, right? So let's say that we're going to bring this text array in so we could check multiple different arrays. So text is going to come in. So what I'm going to do is I'm going to create a counter in my while loop so that I know which element that I'm at. And just like I said, we're going to check the first element, but in the loop, it's basically equivalent to checking whichever element we're at plus the element on the other side. So I'm going to just to make the algorithm easier to read, I'm going to create two variables, unnecessary variables, that define the two letters that I'm checking as letter 1 and letter 2. So like we said in that little pseudocode, we need to check two things. First, we need to check if the letter 1 is equal to a K, right? And I need to check something really quick. Okay. Sorry, not a K, an H. And so that was the first check, and then if it is an H, we also want to check if it's equal to the one next to it, right? So we've already defined those two variables, so we're going to just do the second check. And then what happens if both of those things are true? Then we just want to get rid of one of them. And for this case, it doesn't matter which one we get rid of, right? Because they're both the same. So you can either get rid of the K or the K plus 1. I saw some of you doing this in your codes that you wrote for the exam as well. You do need to be careful. You can't just remove letter 1 or letter 2. Those are just dummy variables that we're saving. You need to remove the actual array element, which would be the text array. Okay, so that is the basic algorithm, and this is a case where two nested if statements are necessary or an and statement, right? So if I did an and between these two, it would be the same as two nested if statements. But again, you should write your codes so that it makes the most sense to you. But the tricky part is that some of you might have had the intuition to just do like a for loop with the for loop running for every element of text. And that's fine if you're doing a filtering algorithm, like we've done that a lot, where you're just replacing a value with a 0 or something. But can you guys think about why you can't do that when you're removing an element? It doesn't have anything to do with the string. It could work with numbers or strings. Yeah, so like length of text, which I have defined, is just the number of characters. It works the same. These commas don't even matter, actually. Text is just like a string of numbers, a string of letters. But
because you're checking the next letter,
you are.
it doesn't know. If you're doing a for loop, it'll only check that one variable at a time.
Yeah, but it will do that with the while loop too, right? It'll just check K and then K plus 1. But maybe I'm not. You could be explaining something else. Let's try it. Let's just see what this does. So that would mean I wouldn't need this counter, right? Because the for loop would do it. So I'm going to call remove duplicates. And I'm going to put in text. Can you tell now? So with the array that I'm using, it's going to take this H out, right? And when it takes that H out, then what is the length of the array then? Now it's going to be 17, right? So by the time it gets to the end, it doesn't have elements anymore because you took them out. So that's a case where you don't know how many times you need to repeat it because you don't know how many you're going to remove. So you don't know how many 2 you're going to check, like how many pairs you're going to check. So this is a type of algorithm that comes up a lot, that instead you want to just reevaluate the length within the while loop condition. And remember, while loop conditions get reevaluated every time the loop runs, where for loop conditions don't. And so as text changes length, it'll re-update it. And then see if that works. And so what we can do is we can output the text array. So I'm not even going to update a lot of people get into the habit of like, this is going to be text orig, this is going to be text new or something, and change the variable, but we're just updating it. I'm going to output the new one, and you can see that it removed all of the double H's.
So if the k plus 1, does it just go to the next variable?
Yeah, so this is going to, we can take a pause and look at it. You can see.
Because I'm thinking, wouldn't that code only work if the h's are right next to each other?
Yes, it only works if they're next to each other.
Oh, okay.
Yeah, so this is a code written for particularly the situation I just explained, where the instrumentation was double counting H's sometimes. So it's a pretty like specific case.
So if it wasn't specific, that would be more complex.
You'd need to generalize it more.
Okay.
Yeah. But does that like basic concept make sense? I always like to show, because we've done filtering algorithms now, I always like to show removing algorithms, because you have to think about them a little bit differently, and then inserting algorithms we'll do at some point, where instead of replacing a value, you need to insert a value. Because as you can imagine, you need to like make room for that.
Well, functions make more sense now.
Yeah, the ones you're using all the time, right? I know. It's like, I've always thought like maybe I should just take like 20 minutes to just explain inputs or outputs or something, but I feel like everything is so overwhelming when you first start using MATLAB that you're just like, that sometimes less information is better. I don't know.